Hi guys, this is Hemant, and today we are going to discuss the security topic how to set up one-way and two-way SSL. When it comes to setting up the secured socket layer, you need to understand two very basic fundamental concepts, that is trust store and key store. The SSL works in a way that a client makes a secured call, an HTTPS call to the server. The server presents its certificates. Client validates those certificates against the CA, certified authority, and the trust is established. So, what are the roles of trust store and key store? Key store holds the private key and the certified public key of its own application, as it is the service provider. Whereas the trust store holds the certified public keys of other applications, the applications from which it is going to take services. This basic concept, if understood well, you will be able to set up your SSL easily. Now, for the sake of this discussion, uh, while we will be discussing the handshake in general, but our focus will be on Java implementation, and Java comes loaded with a tool called key tool, which helps you to build and modify the stores, the key stores or the trust stores. So let's get going. So this is how a one-way SSL will work. So when you are setting up one-way SSL, and if you are a client, then you should get the public certificate from the server application and install it in your trust store. If you already have a trust store, then you should add the certificate chain and the public key to your trust store, or if you don't have, then you should create a new trust store. If you are a server, then you should generate a public private key, get your public key certified, signed, add it back to the key store, and you have to share the signed public key with your clients. So this is how a client will look like. As a client, once you receive the public key or the public certificate from your server application, most probably it will be a .cer file. You double click that .cer file and you should be able to see the certificate. And if you go to the third tab, which is certification path, you will see a chain of certificates. This is a sample you can see. There could be intermediate certificate also, or it might be a two level of certification. So that depends on the organization policy, but you will see the certificate is signed by a trusted certification authority like VeriSign or Symantec. Once you receive the certificate, you have to add it to your trust store. Now, adding to a trust store is not very straightforward. The way you add the certificates to a trust store is you always have to add the root certificate first, then the intermediate certificate if there are, and then finally the public certificate which you receive. So this definitely means that you should extract the intermediate certificate uh, and also the root certificate. I can show you how you can extract the intermediate certificate or a public certificate. So you see here I have uh, I have the public certificate. I double click the intermediate certificate, that was Symantec, and you can see in the certification path, now I see only the Symantec and VeriSign. And then I can extract this by saying copy to file, and this is page 64, and I call it intermediate certificate. intermediate CA, and I save it to the same location, and you see I have an intermediate CA. If you open it, you will see that it has VeriSign as its root certificate. So now we had to get the root certificate. I highlighted, I double clicked root certificate. I went to the details, copy to the file, base 64, and you say call it root CA, and then you next and finish. And that's it. Now you have the root CA, the intermediate CA, and the public key or the public certificate. Once you have uh, all the three certificates, you have to add these certificates as root certificate first, intermediate certificate next, and the client certificate last. This is very important. So once this is done, then you can check your certificates how they are added. You can do a key tool minus list, and if you give the key store name, it will show you all the three certificates attached. The point to note is, if you know that the certificates, the CA certificates, which is semantic and VeriSign, if they are already in your trust store, then you can try to add the public certificate directly. Now, once you have added the public key or the public certificate to the trust store, you have to load this trust store while making a call to the server. If you don't load the trust store, it will not load the certificates you have added, but you may still see that your application is able to make a call. And this is because every JVM, the Java Virtual Machine or the Java Runtime Environment, it comes with a default trust store, and it does hold the root certificates like VeriSign. And that could be the reason that even though you have not loaded your trust store, still you are able to invoke the server application. But the best way to implement your security is to load the trust store in the context and then make a call. So I have put a sample code here. You can see, use the class loader to trust your JKS file, and then you can load this trust material in the SSL context. And once your SSL context is ready, you are ready to make a call to the server. As we discussed, there are two parties while setting up the SSL. We have seen the client part, and now we will look at the server side. So for the server side, as it is the one which is providing the service, it has few additional steps. It has to first create or generate the public private key pair, get its public key signed by the certified authority, add this signed certificate to its key store. So here we are not saying trust store. Now we are saying key store. Now you are ready to share the signed public certificate with your clients. So these are the four milestones which on the server side you should follow. Milestone 1, generate the private public key pair. You can see the command I have given. It will take some input like the organization name, the machine name, the region, the city, town, country. That is as per your organization's policy. And then once you fire the gen key, you will see that a key store is created. And if you view that key store, you will see that this particular key generation key pair has a alias called my app alias, and you will see a private key. So This means that your public key and private key are generated. And if you see the command, we have used a key size of 2048, which is considered safe these days, and it has a 1 year validity, and the algorithm it used to generate the private key pair, private public key pair, is RSA. Once your key pair is generated, you should generate a CSR, the certificate signing request, and send that request file to your CA. CA will return you the .cer file, or the if they send the cr.txt, then if you remove the .txt, you will be able to double click it and open it the same way as we have seen. It will show the signed certificate, which will have a hierarchy with root certificate or root CA at the base. This means, and you can also see the message, this certificate is okay. So now you know that you have a signed public key. The third step is to add this public key to your key store. The rule is again the same. First add the root CA, then add the intermediate CA if it is there, and then finally the public certificate. Now your key store is ready to serve the clients. You can share your public certificate or the public keys with your client, and they on their side can add this public key to their trust store, and this connection or the two parties are ready to communicate with each other on SSL. It is very important to note that while you are sending the public keys or the certificate with your clients, you have to send it very secure. It should not, nobody should be able to eavesdrop and capture this public certificate. Otherwise, it could lead to a man in the middle hack or attack. So I think there are, now that both client and server, they are ready to communicate. From the server side, if you are on the server side, you have to ensure, if you are a WebLogic server or a Tomcat server, you have to ensure that when these servers go up, they do load their they do load their key store, and if they have a trust store, they can load even the trust store. So that, and also to remember that SSL ports are different from the HTTP ports. So please ensure that your SSL port is open to service, and that should be all. That is how you can you are ready to serve the clients. For the developers or the security person who is implementing it, there are few very important tips to proceed. One is, whenever you are trying to test the connection, create a small Java code and turn on the JVM arguments SSL and handshake. Once you turn on these two JVM arguments, you will be able to see what is going on your side of the application. It will print whenever a request is generated, or what all stages the request is passing, and at what stage it failed, if at all it failed. And this is very important during the initial setup. So this is how you set up a one-way client and one-way server. So now there are cases wherein you want to do two-way SSL. So if you want to do a two-way SSL, the part one of one-way SSL is same, that application 1 acts as a client and application 2 acts as the server. But then there is one additional step, that is, once the client to server, that is application 1 to application 2 trust is set, then application 2 becomes the client and application 1 becomes the server. So this is interesting, and you see, this is two-way trust. This is called a mutual SSL setup. But the basic steps remain the same. As a client, you get the public keys from the server, store it in your trust store. As a server, you create the public private key and hold it in your key store. For step 2, the same thing happens, that as application 1 becomes the server, application 1 should generate a public private key, hold it in a key store, and it should issue the certified public key to the client, which the client, in this case application 2, should add to its trust store. And once this part is done, I think you are ready to go. So basically in one way and two way SSL, the basic concept, the basic underlying concept is same. The only additional step which is required is each application has to work as client at one point and server at another. So that's it. I hope this will help you to set up your SSL connections, and thank you very much for this session. We will be coming up with more sessions wherein we will go beneath the layer, that how these SSL connections work and what are the different stages in one way and two way SSL communications. Thank you very much.